sounds good. Thank you. Okay, so I'll share my screen. Hi, everyone. For those who weren't in my exercise yesterday, my name's Nick Van Handel. I'm a grad student at UCSC in the linguistics department. And so today I'm going to walk you through an exercise looking at constraints on codas in Japanese, or data that's sort of Japanese-like. At any time, if you want me to slow down or repeat something, or you have any question, feel free to interrupt me. You can raise your hand using the Zoom function. And then also at different places, just to make sure we're all on the same page, I'll ask you to give the thumbs up reaction, just so we all know there's no issues or anything. Great. Okay, so the basic pattern that we are going to be looking at today is a pattern that we find in Japanese where only homoorganic nasals can be codas. And when you have underlyingly a coda and a following consonants that differ in place of articulation, the nasal changes its place of articulation to match the following consonant. So for example, if you had an underlying form like kanda, well, N and D are both coronal, so those already match in place of articulation, so there won't be any change in the output form. But if you have something like kamda, where you have a labial nasal followed by a coronal stop, that M will change to N, and you'll get kanda on the surface. Similarly, if you have N followed by B, that N will become labial. It'll assimilate to the following bilabial consonant. Of course, there are other patterns that we find across languages. So some languages are really liberal with what they allow to be a coda. So any consonant could be a coda. Others resolve the conflict in place of articulation by deleting non-homoorganic codas. Some will epenthesize to resyllabify the non-homoorganic consonants. So they'll put a vowel like between the N and D to make it Kanada. That way the N becomes an onset. Other languages where codas aren't possible will epenthesize to repair all codas, or they will just delete all codas. And yeah, thanks Michinori for sharing the link to the handout. Great. So are there any questions right now about just this basic pattern we're going to be looking at? I just want to check the handout link quickly. Oh yes, this was a PDF. I actually did make slight changes to the Google Doc itself, so I'll send you a link directly to the doc. So this link that I'm putting in the chat is just a slightly updated version of the PDF. So you might want to follow along on the link that I just sent. I made a few tiny changes. Okay, so as Jenny talked about in the main lecture, whenever we have an OTWorkplace system, we first start by figuring out what gen is. So what's our candidate set? And so for that, we need to define both our inputs and our outputs. So for this sort of toy language or toy system that we're making, we're going to have 4 different inputs. They're going to be of the form ka, consonant, consonant, a, where C1 is a nasal consonant, N or M, and C2 is a voice stop, B or D. So we're just looking at labials and coronals for this. So if you substituted N and M in for C1 and B and D in for C2, we end up with 4 possible inputs. Kanda, kamda, kanba, and kamba. With that as our starting point, we can start putting our inputs into OTWorkplace. So what you'll want to do to get started on the OTWorkplace part of this is open up a new Excel workbook. So it should be a blank workbook. And then you'll click on add-ins. You'll go to OTWorkplace, and then project start. Once you hit project start, this pop-up will come up and you'll click on new name. And so we'll give our project a name. To keep things simple, we can just call it CodaCon. Then you press OK. And then OTWorkplace will give you sort of this template where we can start putting in our inputs and then later our outputs and our constraints. Was everyone able to get to this point where you see the name of the project and then input, output, opt, and constraint one here? Could I have a thumbs up reaction if you're able to get to that point? Okay. I see 4 or 5 thumbs up, so I think most people have gotten it. Feel free to interrupt if you need help or want me to review that again. Okay, so as I was saying, we have these 4 inputs that we're going to want to use for this system. And so we can start putting them into our input column. We're going to change this slightly eventually, but we can start with putting Conda here. One thing that we might want to include is a syllable boundary, because we want eventually our constraints to know, like, what are the codas, what are the onsets, and once we write our regular expressions for the constraints, it will be easy to make reference to codas and onsets if we put a period where every syllable boundary is. So that's the one change we're going to make from what this underlying representation over here is. We're going to add that period between N and D. And then we'll get to the outputs eventually, but I'll just say right now that there's going to be 6 outputs for each input. So I'm going to space out the inputs so that there are 6 outputs for each one. So 1, 2, 3, 4, 5, 6. So then we'll start the second input here. That's Conda. And then we'll go down 6 more. 1, 2, 3, 4, 5, 6. The next input on our list is Conba, N and B. Then we'll go down 6 more again. 1, 2, 3, 4, 5, 6. And our last input is going to be Comba, M and B. Okay, so any questions so far about the inputs, or like why we use this period here? Or are we ready to go on to the outputs? So with those inputs in place, we can then think about our outputs. So as I was saying before, there are different patterns, some where you change the place of articulation of the nasal to match the following stop. But there are also languages where we get deletion or epenthesis. So in our outputs, we're going to want to have candidates where you get changes of place of articulation, deletion, and epenthesis, so that we can cover the full range of patterns that we find. So we have this sort of formal definition of our outputs here, but it's a little bit complicated to go through. So I'm going to just skip down to show you an example. So if we look at the input Conda, we're going to have 6 different types of inputs that we'll consider for our basic system here. The first will be the fully faithful candidate, where you don't change any of the consonants. We're not epenthesizing any vowel. Everything is the same. So we'll enter that as our first input here. Our second input is one where we change the place of articulation of the nasal to make it, in the underlying form it was a labial, so now we'll switch it to make it coronal. So that we will enter as Conda. And then here actually, there's another point I want to make, which is we want OTWorkplace to know whether a nasal stop was in the underlying form or whether it was a change of place, because OTWorkplace itself doesn't necessarily, it can't evaluate correspondence relationship. So we have to put extra information into the representation so that OTWorkplace's constraints can assign violations when there's a change in place of articulation. So the way that we're going to represent a change in place is by using a capital letter for whichever sounds got changed. So in this case, the segment M was changed to an N. So we'll use a capital N. So this will become clear later on when we write our constraints, how this is useful, but just note, capital letters mean there was a change in place. For our third output here, we have another change of place of articulation, but this time it's on the third consonant, D. It's underlyingly D, but in the output that we're considering, it's changed to B. So that means once we enter this output here, we'll use a capital B to show that D has changed to B in this form. The next two outputs we are considering are those where you either delete the onset or you delete the coda. So we're going to follow what Jenny did in the lecture before, where we'll use a capital X to show that a segment was deleted. So in this case, when the onset is deleted, we'll use a capital X after the period. And then in the other case, where we have the coda deleted, we'll put the X before the period. And so then our constraints later on will be able to reference, for example, our max constraints that say don't delete, we'll be able to look at these forms, they'll see an X and they'll know I should assign a violation to this because there was deletion. The last candidate that we'll consider is one where instead of changing anything about the consonants, we insert a vowel between the nasal and the following stop. So here, again, to show that this is Epenthesis, now we'll write the A with a capital letter. And so that's just so that we know there was a change from the underlying form here. This A wasn't in the underlying input. So we'll follow the same basic steps for the rest of the inputs. But just to review, we have our fully faithful candidate, changing the place of the nasal, changing the place of the stop, deleting the onset, deleting the coda, and then inserting a vowel. So at this point, I'll just pause and ask if there are any questions. If not, if you could give the thumbs up reaction that you have these 6 outputs in your worksheet. Sorry, I'm trying to move around all the Zoom windows to see everything. Okay, great. It looks like most people have gotten there. Okay, so then we'll do a similar thing for the rest of them. So first we want our fully faithful output. So that will just be kanda, nothing changes. Next, I want one where we change the nasal from N to M. So how would we write that? If I was going to write out this output, you can put it in the chat or say it out loud. So we want the output where the nasal changes place of articulation. What would I write that as?
With a capital nasal?
Exactly, yeah. So here, yeah, and Maho also put it in the chat. We do it with a capital M to show that N has become labial now. Exactly. Then the next option is where we instead change the place of articulation of the stop. So we'll do that by doing a capital B. The next two are our deletion candidates. So either we delete the onset, again representing that with X, or we replace the nasal or delete the nasal So there we have an X where N was. Yeah, so that's a great question. Someone in the chat asks if we should apply resyllabification to candidates like com-a or con-a. I think normally we would want to do that for those candidates. In the data set that Jenny created, she did not apply resyllabification. And I think that's because we want to simplify things a bit for this basic system. Because we want to get an asymmetry where we can have codas delete, but not onsets. And basically we're trying to get that asymmetry without introducing additional like positional markedness constraints, positional faithfulness constraints, which might be a little more complicated than what we want for our simple system here. So yeah, if you're doing like a more detailed analysis, then you would probably also want to include a candidate that has resyllabification like this. But we're going to set that aside for now just to simplify for this tutorial. Yeah, it's a great question though. Great, and then our last candidate is going to be the one where we get Epenthesis. And so that will be Canada. Okay, so if there aren't any other questions, then I'll go a little faster just filling in the rest of these. But please feel free to interrupt. So again, with Kamba, we want our fully faithful. We want the one where we change the nasal, so N becomes M. Then we change the stop, B becomes D. Then we delete the stop, so B becomes X. We delete the nasal, N becomes X. And then we apply Epenthesis, so we get Ka-na-ba. Is that right? Yes. And then I'm gonna scroll down slightly just so we can fit everything. Okay, we'll do this for the last input then. Our fully faithful output, our output where we change the nasal, our output where we change the stop, our deletion of the onset, deletion of the coda, and then Epenthesis. And making sure at each step, whenever there's a change, so change of place or the insertion of a vowel, that we use capital letters. So I think this is right. Correct me if you notice any errors I made, since I just generated those off the top of my head. But at this point, again, I'll just ask for thumbs up if everyone has all the inputs and all the outputs. And if not, let me know if you want me to show a different part of my screen so that you can get everything. Okay, great. So after that, we now have our gen set. So we next want to work on con. So for this system, there are 6 constraints that we're going to use. 4 faithfulness constraints and 2 markedness constraints. And so we're going to define these using the regular expressions that we saw a little bit of in Jenny's earlier lecture. So I'm just going to try to scroll up here. Trying to make sure I can keep everything on the screen, at least for now. So we can start by talking about our f.max constraint that says don't delete. And so we want to use a regular expression that will penalize any output in which we have deletion. And so this is where the representation we used will come in handy, because in all of our cases where we had deletion, we represented deletion with a capital X. So to write a constraint that will penalize deletion, all we have to do is write asterisk followed by a capital X. And so once we evaluate this constraint, OTWorkplace will look through every output, and every time it finds a candidate with a capital X, it'll assign a violation. So that's why it was important to represent deletion in the candidate with a capital X. If we didn't have anything at all, then it would be harder to identify those cases where there was deletion. Okay, the next one then is going to be our depth constraint, so don't insert. So based on the representation we used, does anyone have an idea for how we should write a regular expression for the depth constraint? So we want a constraint that will penalize any candidate where we inserted a vowel. So how might we write that? Yeah, exactly. So several people in the chat have said we want to write star A, and that's exactly right, because star means assign a violation for any instance of the capital A. And we only use the capital A whenever a vowel wasn't in the underlying representation. So this is why it's really important for us in our representation to distinguish between the lowercase a's, which were already there in the original form or in the underlying form, and then a capital A for those that got introduced. Because now we can tell OTWorkplace to only find certain vowels, those that weren't in the underlying form. Our next constraint then is going to be ident place, which says don't change place of articulation. And so this one's a little trickier because we're going to be penalizing multiple things. So basically we want to penalize any case where we had a nasal or a stop that changed its place of articulation. And remember that we represented those changes with capital letters. So for this, what we can do is write the asterisk, and then M is one of the things that changed. And then to tell OTWorkplace to look for multiple things, we can use a comma and a space. So we want it to find any capital M, but also a capital B, a capital N, and a capital D. So this way OTWorkplace will know whether you were a nasal or a stop that changed place, I'll assign a violation to you. Our final faithfulness constraint is going to be ident stop. And so this one is different from ident place because it's only going to penalize the change of articulation for oral stops. So it doesn't care about nasals at all. So if we only want to penalize candidates where the stops change place of articulation, how might we write a constraint or the regular expression so that it only identifies those stops that changed? Yeah, exactly. So here we can write star B, comma D. Maho in the chat wrote it with a star between both letters, but I actually think, I'm not quite sure about this, but I think for it to work in OTWorkplace, you want to be sure you only put the star at the very beginning of the expression. You don't want to have it in both places. But yeah, that's exactly the right idea, that now we're only penalizing stops that changed, but we're going to let any nasals that changed, we're not going to assign violations to them. So those are faithfulness constraints. Before we go on to the markedness, I'll just ask a quick check-in again, thumbs up if everyone has this down, or if there are any questions, feel free to ask. So I'm going to try to make everything fit onto the screen. We might have to switch back and forth a little bit. But our next constraint is no coda, and here we want to penalize any instance where we have a coda consonant. So in this case, there's 4 different coda consonants that we find in the outputs we have here. So we have an N that is underlyingly an N that hasn't changed in the output. So we can have an N as a coda. We can have an M as a coda, and that's an M that was not present underlyingly, so it changed. We could also have an M that existed underlyingly that's in Coda position. And then we can have an N that was originally an M in Coda position. So that's a lot of words. Basically, all it means is that we want to write our constraint so that it will penalize having nasals before syllable boundary. And we want to make sure we include both those nasals that kept their original place of articulation and those that changed place of articulation. So what that means for the way we define the constraint is, first we'll say penalize an N at a syllable boundary, and penalize it whether it was underlyingly an N or whether it became an N after changing place. And we'll also say change an M that's before syllable boundary, and that could be either an underlying bilabial or one that took on labial place afterwards. And so for all the outputs we consider here, we only ever had nasals in Coda position. So this will get us the violations we want. If you were doing a more complicated output set where you also had other types of consonants in Coda position, so let's say you had something like, maybe we consider a candidate where instead you become oral, you lose your nasality, then we would want to add like D to our list of no Coda. But since we're not considering those candidates, this definition will get us everything we need. And then our last, that's exactly right, yeah. So using the period and the constraint definition won't be a problem for the regular expression. It'll just treat it as another character that it looks for. And so, yeah, it's different from the commas. So the commas, when you put them in the regular expression, it sort of separates like what are the different sequences you want to look for. But a period will actually be searched for. Okay, and then our last constraint is what we're going to call Coda cons. And so this is going to be our constraint that will assign a violation for every Coda segment that is not a homoorganic nasal. So here it's going to be either a sequence of M followed by D or N followed by B. So this one's going to be a little more complicated because we want to be assigning violations to sequences of multiple segments. So does anyone have an idea of how we might write this constraint to rule out, say, N followed by D? Or sorry, N followed by B? Yeah, exactly. So we can start by doing star M dot D. And so this will look at a case like, yeah, our second output candidate here, we have M followed by D. That violates Coda con. So we'll put capital M followed by D into the constraint. There are a few other cases of non-homoorganic sequences that we want to penalize. So what else do we need to put into the regular expression? Yeah, so we'll also want lowercase m followed by D, because it doesn't matter whether this was underlyingly labial or not, it's still followed by a coronal, so you want to penalize both of those. And then there's also the flip, where it's a coronal followed by a nasal. So we'll also want to penalize n dot b, both for the capital letter and the lowercase n. Yes, and I want to make sure we haven't missed anything.
What about the opposite, like M plus M dot capital D?
Yeah, you're right. I was just thinking through that. I realized I missed those. That's exactly right. So we want to have also M dot capital D and N dot capital B. So those cases where instead the stop changed, but we still have different places of articulation. And I think that should be all of the cases. Can anyone think of other ones? I think that covers it all. Okay, so those are all of our constraints. So now just once more, does everyone, if I could get a thumbs up, just that you have your gen set like this, you have the constraints with their definitions. Okay, great. So at this point, we have our definitions. Now we want OTWorkplace to actually use those definitions to assign violations. So to do that, you'll click again on this OTWorkplace tab. You'll go down to gen and eval, and then you'll select evaluate all constraints. And so, yeah, everything worked out. Oh, Maho, notice a possible error. On row 23, there's com.da, but should it be com.da? Yes, thank you, Maho. So if anyone was using the inputs that, the outputs that I wrote, I had a typo in row 23. It should have been com.da because it was an M underlyingly, and that M hasn't changed. So I'm just gonna run evaluate all constraints again to fix that. I think that, did that change it? Actually, I'm just going to clear it and then evaluate all the constraints to make sure that everything's evaluated correctly. Okay. Okay, I think that should be good. So has everyone got into the place then? Could I see a thumbs up where you have all the violations assigned? Okay, so yeah, hopefully this shows kind of like how useful it is to use the regular expressions and to introduce like capital and X's to keep track of different things, because you don't have to calculate any of these by hand. So the next step then is to actually run our factorial typology. And so to do that, once again in Excel, you'll click on the OTWorkplace tab, and you'll go down now to factorial typology, and then you'll click on fact type calculate. So then you'll get this little message that tells you there were 24 total candidates. 10 of them are harmonically bounded, so they'll never be optimal under any ranking. And then there are 14 optima left over. Click OK. And now it tells us that given this gen and this con, we predict 6 languages to be possible. We could issue the ranking information on all of them. As Jenny said, sometimes it takes a little bit of time. I don't think it'll take that long for this since it's a relatively small set of candidates. So let's say yes, issue ranking info on all. Okay, I said that and now it's not moving. But hopefully, yeah, so OTWorkplace will start going through the math to find all the constraint rankings for these different languages. And then if at the bottom, you see these little tabs here, there's now a tab to different language with its ranking. But if you click back to fact type Coda con, we can just look at all the different languages at a glance and sort of figure out what strategy does each of these languages use. So remember at the beginning, we talked about how there are different patterns that we find. You could have a language that changes the place of articulation of nasals. Oops, not gonna do that. You could have a language that allows any consonant to be a coda. You could have a language that deletes codas, and then it could maybe delete only the nasals, or it could delete any coda, or it could have epenthesis instead of deletion. So there's all these different repair strategies. So if we look at each of these different languages, we can identify which strategy each language uses. So the way we do that is we can compare the inputs here. So these are like the underlying forms. And then for each language, it says this is the optimum for this input in that language. So in language 1, underlying Conda becomes Conda, Kamda becomes Kamda, Kanba becomes Kanba, and Kamba becomes Kamba. So there's no change here between the underlying representation and the optimal candidate. So we could say maybe that this is like the faithful language. It tolerates codas, and it also tolerates differences in place of articulation. How about this next language? So here, Kanda becomes Kanda, so it remains the same. But when we have Kamda, that M changes to N. And similarly, Kamba, N changes to M. Whereas with Kamba, nothing changes. So if we had to describe this pattern, what might we call it? Or what might we call this pattern for language 2? Yeah, so this is our nasal assimilation language. And this is basically like what we would find in Japanese, where you change the place of your nasal to match the place of the following stop. So now that we found these two languages, if we have time, we can return to go back and look at the other ones, but it might be interesting to compare their rankings. So for our fully faithful language where nothing changes, if we click on L1 here, it'll take us to the page with all of the ranking information. And perhaps unsurprisingly, if we look at the Hasa diagram, three of our faithfulness constraints are ranked above the other markedness constraints. So for example, don't epenthesize is above no coda and coda cond. So that explains, for example, why we get kamda instead of kamada, because our constraint that says don't insert anything is above the constraints that say codas are bad, or that a coda should have the same place of articulation as the following stop. Similarly, max is ranked above no coda and coda cond. And we can see why if we look at kamda versus a candidate in which we deleted the nasal. Here, max is needs to be ranked above both of those because the losing candidate performs better. It avoids having a non-homorganic coda by just getting rid of it entirely. So to have something that's fully faithful, we need max to be ranked above these two constraints. So that's the faithfulness language. Then we can look at our nasal assimilation language. And in this case, we should expect our markedness constraints to be ranked above the faithfulness constraints, at least some of them, because we do change the place of the nasal. So here the ranking is a little more interesting because we have some markedness constraints over faith and some faith over markedness. So remember, in this language, an input like kamda will change the M to an N. And that means that coda cond needs to be ranked above ident place because it's better to change the place of articulation in order to get a homorganic sequence. So we see that if we look at, let's see, Kanda versus Kamda, the changing winner is preferred. Another thing we see is that we prefer to change place of articulation instead of inserting a vowel. So that means that dep must be above ident place and no coda. And so what's really nifty about OTWorkplace is it doesn't just show you the ranking, but you can then look at these crucial pairs of winners and losers and see why, for example, max needs to be ranked higher than the other two constraints. And so we could do this, for all of the other languages in the set, looking at all of the different rankings. One other feature I'll just mention, which I think Jenny talked about also, is where you can go to OTWorkplace ranking and then gather MIBs and HASs. And this will actually take for each language, it puts it onto a page where you get the crucial rankings and the HASA diagrams. You can sort of compare everything at a glance. So there's different ways, I guess, you can think of it as different ways of visualizing the information that OTWorkplace gives you. I'll just point out language 3, when the nasal and the stop share place of articulation underlyingly, we find the same thing on the surface, but when they differ in place of articulation, the coda gets deleted. So we could say that this is the language that deletes non-homoorganic codas. Language 4 is a language that, again, is fine with a coda when they're homoorganic, but when they're not homoorganic, it actually epenthesizes a vowel. So here we can talk about this as epenthesizing for non-homoorganic codas. Language 5 just deletes codas across the board, so you never get a coda. And then language 6 epenthesizes across the board, so it always epenthesizes. And so you can see how our factorial typology now has all these different patterns that we talked about at the outset. Okay, so that's all I have. But if there are any questions, I'm happy to answer them. Otherwise, thanks everyone.